In this video, we are going to calculate the rate of energy emission by a wire. So the question says a hot tungsten wire filament has a radius of 0.6 centimeters at a temperature of 300 kelvins and emissivity of 0.74. Calculate the rate of emission by a 1 meter length of the wire. Ignore the radiation received from the surrounding. So here the data we've been given is a radius of a filament wire, which is 0.06 centimeters, which can be converted to 0.006 meters. Then the length of a wire, which is 1 meter. The emissivity is 0.74. The temperature given is 300 Kelvin, and the energy rate is what we need to find, and that is just the power. The energy rate, the rate at which the energy flows is power. So that is what we're going to find here. Now, there is an equation that we use to find, or rather to work out questions of this kind, and this equation is this. Where this is the energy, the heat energy, this is the time, and this is the emissivity constant, this is the Stefan-Boltzmann's constant, and this one is the area, and this is the temperature, which is raised to the fourth power. So this is the formula. So E is the emissivity, yes, the emissivity, which is a constant, and this one, Stefan-Boltzmann constant, it's so this one is given by 5.67 times 10 to the power negative 8 watts per meter squared per Kelvin raised to the power 4. So that is the constant. And here, so this is the rate, which is the power. So we can even say power is equal to E, then the Boltzmann's constant, A T to the power 4. So now, looking at the information that we have this, and area, the temperature we have. So what we need to find is simply the area. And how are we going to calculate the area? We have been given the radius of a filament, where when we hear of the radius, we hear something, or we need to come to say there is something like a circle. A circle is something, or something circular is what has a radius. Now, so how are we going to find now, since it is a wire with length 1 meter and the distance, or rather the radius is 0.006. So what we need to do is we need to find, or rather we need to recall that the area, the total surface area of a wire given by a certain radius, and the length is given by 2 pi r L. So we can put in the values now. And what we're going to find when we plug in the values, what we're going to find is so this is the value for the area. Now, if we plug in the values for area and the information that is given here, we are good. Okay, this, so let's now plug in the values. For A, it is 0.74 times 5.67 times 10 to the power negative 8 watts per square meter per Kelvin raised to the power 4 times the area 0.038. The squared times 300. So 300 and 300 when it is raised to the fourth power, so 300 to the power 4, we are going to have 4.35 times 10 to the power 12 Kelvin to the power 4. So that a Kelvin to the power 4 and a Kelvin to the power 4 will cancel, and this square meter and this one will also cancel. And what we're going to have is 12.8 watts. This is the only unit that is going to remain after others have cancelled.